So today we're going to talk about the arithmetic mean, geometric mean inequality, which basically says that given positive real numbers, let's say a and b, let's say a is bigger than 0, b is bigger than 0, then the average, or the arithmetic mean, a plus b over 2, is always greater than or equal to the geometric mean, which is the square root of a and b. Now I said they have to be positive real numbers. Well, why not negative? Well, if one of them is negative and the other one is positive, then inside the square root you get a negative number, and we don't really have a way to compare complex numbers. You can't really write inequalities like this. Now, what about if one of them is 0? So notice that if a is 0, then square root of ab is just the square root of 0 is 0, and a plus b over 2 is just b over 2 is bigger than or equal to 0. So there's nothing to show. This inequality is trivially true. Right? Now what we want is, of course, the general case, that if you have positive numbers, then this is always true. Case like when one of them is 0 is easy to prove. So let's write down an algebraic proof. Why is this inequality true? Okay. So this is one of those cases where we start with what we want. We want that a plus b over 2 is bigger than or equal to the square root of ab. We kind of work backwards and see this is going to be true if the next step is going to be true, and that's going to be true if the step after that is going to be true, until we come to a true statement, and then we can just work our way back. Okay, so this is true, then by squaring both sides I get this also has to be true. Now of course when you're squaring, you have to worry about what happens to inequalities. Inequalities can flip sign when you do such things. However, everything inside is a positive number, so this is still okay. So you can still square, this is positive, and this relationship, this inequality is still going to be true. But what happens to the left side? We can expand it like this, and the right side is just AB. So if this is true, then this has to be true, and if this is true, then this has to be true. Well, what is necessarily true if this last statement is true? Multiply by 4 and I get that. And then finally this is going to be true if this following statement, by subtracting 4ab from both sides, is true. So now is this true? Because the truth of this hinges on the truth of this. Well, notice this left side is simply a minus b squared. So we're really asking, is this true? Well, sure. No matter what a and b are, whether they're positive or negative, certainly a minus b doesn't even matter whether that's positive or negative. The square of any real number is always greater than or equal to 0. So yes, this is true. And therefore we just zoom all the way back and we get this famous inequality that the arithmetic mean is always bigger than or equal to the geometric mean. Well, is there another way to see the same thing? So what we're really asking is there a geometric proof, a visual proof? As the old Chinese proverb goes, a picture is worth 1,000 words. So let's draw a picture. I'm going to draw a big giant square. Like like this. And the size of the square, that is each side length, is going to be a plus b. Recall, we still want a plus b over 2 bigger than or equal to the square root of ab. So I'm going to choose a square of length a plus b and height, width a plus b. And I'm going to mark off, let's say this is a, this is a, this is a, and this is a. So here's a, here's b, a, b, a, b, a, b. And then I'm going to draw these rectangles like so. Okay. So what is evident from the picture is, well, the area of the outer square is just the side length squared, is a plus b. And the square contains the 4 rectangles inside it. Therefore, this is bigger than or equal to the area of the 4 rectangles. Well, what is the area of each rectangle? It's b times a, or a times b, and 4 times that. So the area of these 4 rectangles is 4ab. Okay. So in fact, we get a plus b squared bigger than or equal to 4ab, and this is proof by picture. Big area, 4 smaller areas, and this is the leftover area. It's in fact, this is bigger than this by this much. Now divide by 4, I get a plus b squared over 4 bigger than or equal to ab, or a plus b over 2 squared bigger than or equal to ab, which is nothing but the statement and what is the error? So the arithmetic mean is bigger than or equal to the geometric mean by this much. The picture is telling you what is the error between the two, and the error is exactly what we saw already. It's a minus b squared. That is, the area of this little square is a minus b squared, something that you can try to convince yourselves of. So there we have it. The arithmetic mean of 2 positive real numbers is bigger than or equal to the geometric mean. And we have seen 2 different proofs of this fact.